Hello and welcome to this talk. I can barely see you all, so if you have any questions, if you have any comments or anything, you're more than welcome to do that while I'm presenting, but you need to shout or throw something at me, because I can barely see you. Just don't throw too heavy things. All right. Water bottles, maybe. Not glass ones, maybe. Okay, anyway. Let's get started. So, Java in the cloud. What does it mean? Like, why do we really need to think about this, and what is so much different from just the regular kind of Java applications that we've been developing for quite a while? I've been doing that. I've been developing Java applications for, well, as professionally at work since early 2000s. As a student and developer and that kind of things, even earlier, so even further back in time. But you know, things are changing now. We've had cloud for quite a few years, and we also had new developments in Java. We have that, a lot of things happen. So let's have a look what really is different. And I also want to talk a little bit about the enterprise part of it, and that's what a lot of us doing EE kind of applications a lot of times. Whether we like to admit it or not, or whether we actually think we're doing that or not, a lot of us, if you're doing it professionally, you're doing some kind of enterprise something. So Java EE, Jakarta EE, you know, all the other ones as well. So, my name is Rustam. I am Java champion, Google developer expert for cloud. I'm a Docker captain, a bunch of things, and I work with Java. I've been doing that, like I said, for quite a few years already, and I've been also a consultant for many of those years, and now I'm not anymore. So I'm doing more in-house kind of development, but still, most of the things that I've been doing throughout the times has been development. It's been developing on JVM platform, Java, Kotlin, you know, the other things. And it's a little bit of a mix of my experiences and also things that I've been playing around to see if we can actually bring to our applications or bring into our platforms as well. So a little bit of experimentation, a little bit of experiences, and that kind of things that you will be seeing today. So if you want to find me on social media, just go to that website, rustam.no. You will find a bunch of links to different social medias that you prefer. I just got tired of listing all the handles there. All right. So what we're going to see today, and that is what are the options? What can you actually expect? How you can expect to deploy your Java applications? A really quick intro there, just to set the stage. And also we're going to talk about the modern Java applications and what is different from the way we used to do that before. We're going to talk a little bit about serverless. We're going to talk about optimizing things and making it go a bit faster. It's fast already, but you can actually add some more stuff to it. We're going to talk about things like native images. We're going to talk about crack. It's not about drugs. Just saying. Yeah. If you're here for that, then you're probably in the wrong room. But we'll talk about different kind of crack. Right. So options, well, you know, typically this is just an example. Your platform might differ, your stack might differ and everything, but this is just a typical example on the cloud. This is an example of Google platform, but it's the same. Very often it will be very much the same picture, but just the different names, no matter what cloud provider you're using. So typically you will be either running it on some kind of compute, and by that I mean you're renting or using CPU and memory, CPUs, RAM, and disk, and then you're doing stuff on top of that. It can be just simple VMs, it can be Kubernetes of some kind. And the other one would be typical, a serverless offering of a sort. So in this case, it's some kind of cloud functions, Lambda functions. It's called different in different different platforms, but small, tiny little things. It will be also another kind of proprietary way of deploying your applications. In this case, it's called App Engine, and that's a little bit bigger kind of applications, but it's still proprietary, specific to a cloud. This is for those of you who kind of like a bit of a history. This is probably, I don't know, it could be argued that that was kind of the beginning of the whole cloud thing. Before it was called cloud, was the App Engine, where you could just deploy your containers and just make it run and everything. But the point is, it's specific to a cloud provider. That's totally fine. You still can do a lot of things that we're going to talk about there, but I want to talk a bit more about something that is more portable. And on that cloud, it's called CloudRun, but also there is another way of running that, which is open source and very, very much compatible in API-wise and functionality-wise and all that. It's called Knative. So why we're focusing on that? Well, because we're going to, when we talk about containerization and we're going to talk about running things on a serverless, it is full-fledged container. It's actually a container that you can pretty much deploy there or run on your local machine or run on Knative on your own. But for those of you, how many of you heard of Knative? Okay, that's too many, too few hands. So Knative is an initiative, like it's now under Cloud Native Foundation. It's an initiative started with a bunch of companies, Google one of them, but there was a bunch of others, Pivotal, I think it was Red Hat, and there was a few others. The idea is, so you take Kubernetes, you put on top of that some kind of service mesh, and on top of that you have a Knative installation as well. It has two versions, so you can do serving or event-driven, or basically more like a server-like thing. And then you can pick and choose, and then you can run your applications serverless on your own on-prem, basically, or somewhere else. So the reason I'm picking that one is, like I said, again, it is a full container that is not dependent or on anything on a platform, so then you can deploy it wherever you want. You want a Kubernetes cluster? Fine. You want a Knative? That's fine. You want to go to some kind of serverless managed services? That's fine as well. You don't really have to do any changes. Right, now, so that's the platform thing, so we can put that to the side. Now, what does it mean with modern enterprise kind of stuff? By that, just to describe a typical application that we can be using is that it is typically some kind of, like I said, EE stuff. In my examples, I'm using Jakarta EE, I'm using microprofile. You can use Spring Boot. You can use Micronaut. You can use whatever you want. I had to pick something. I chose that. Jakarta EE, anyone? Okay, there's too few hands again. J2E, Java EE, yeah. So whichever of those words I say, you can safely raise your hand. It's the same thing, it just changed its name a few times. Microprofile was a kind of a bit of an addition on top of that to make it more friendly for microservices and stuff. I'll explain why. So this is Jakarta EE, what it is now. It used, like I said, it changed names a few times. It's been moved from from Sun, then it went to Oracle with acquisition. From Oracle, it went to Eclipse Foundation at some point. And now it has become, so now Jakarta 11, E11 is about to be released. I'll show you a little bit of updates on all that. But for now, since that's the main version that's available, I'm going to stick with 10. It has different profiles. So you have the smallest one, which is core profile, but then you have also a web profile and a full profile or platform. Then we don't really need to think about all the other things. The important stuff here is the core profile and doing dependency injections and the RESTful web services and all this kind of CDI and all this kind of things. And the reason why that is important, is that we take that, we put that into a tiny little box called their Jakarta EE10 core profile, and then add a few things on top of that. And those things really make your application a bit more cloud-ready, cloud-friendly, because now all of a sudden you have out of the box, you have an OpenAPI spec that you can generate. You can also do that metrics, you can do things with health, you can do with config, REST clients, all those kind of things. Again, this is a way of building applications. You can build it with something else, and you can still apply a lot of those things that we're going to talk about. A lot of those things you can find easily in things like Spring Boot or anything like that. Right. This, as I promised, this is what's coming on the Jakarta 11 platform, but this has nothing to do with what I'm going to be talking about, so this is just for your own curiosity, for your own kind of information thing. Right. So I have a few examples, and this is the examples that I'll be referring to, but just to give you a little bit of a taste. So basic stuff that I'm going to talk about, like basic example, not basic topics, but basic examples, is this repository called random strings. And then I have a bit more advanced example of using cloud native and creating those modern applications using things of health and everything. That's the 5 features, the repo below. That's a bit of the background. Now, let's go serverless. So we want to create an application and we want to optimize it. And why do we want to optimize it? Because back in the days when we would develop applications, it would be, we wouldn't care much about, time it takes to start up application or time it takes to memory footprint it takes or everything, because you would just have a box. You would just deploy it, start it, and it would just work. And then we didn't really have to think about or get bothered by things like startup times, for example, right? Cold starts. I remember, like back in the days in early 2000s, like I said, you would create an application, you put it on a physical server, not even a VM, on Tomcat. You just deploy that thing and just let it run. If it had memory leaks, we would just create a reboot on Sunday, so it's fresh and new on Monday, and by Friday it will get kind of laggy and weird. We'll reboot it again. So we didn't really bother much about all these kind of things because it's just running there. And when we had issues with cold starts, when people on Monday would complain that, it's just a little bit slow, then we just added a little bit to that scheduled job where we would just ping an endpoint once after it's booted early on Monday morning or somewhere at night. So it has this kind of everything is warmed up and loaded into memory. And after that, it will just be fine, right? Now that's one of the reasons I'm bringing serverless, is that now you're getting forced to actually do a bit more optimizations, because now you can scale things up and down, maybe even to 0, or not even to 0, but just from 1 instance to 100 or 10 or whatever. And now you have to think about optimizations and that kind of stuff, right? So just a quick recap. Serverless, to me, it actually means manageless. You still have servers, but you'd have to manage less. Most of the times, most of us are developing something not that big that requires a full Kubernetes cluster. I have deployed before tiny little applications on 3 nodes, huge Kubernetes clusters. It worked. It did cost me a lot of money for nothing, for idling, but it worked, right? But most of us, unless we're doing really, really heavy trafficked applications, maybe it's not a necessary thing. So that's why you might want to go serverless, as a consider at least going serverless, no matter if you're running it on a cloud, on-prem, whatever. It also has something about the running costs, and usually I say serverless is about something green, depending on what green you care about. So, when you're saving costs, you're saving money, obviously. That's one green thing. And the other green thing is environment, because you do use less of resources, so you can let those resources make those resources available for something else, and then it will be less resources used, less electricity, and all the other green things that a bit more important if you ask me, but that's a different story. But the downside is now you have to think about startup times. You need to worry about cold starts. You need to think about what happens to your container from you have built and created it till it's able to serve the first request. And we'll talk a bit more about that. And also it's about flexibility and control over your containers as well, because, again, you have a chance to do more because now it's a portable container, actual container, so you can actually run the same thing no matter where you want to go. The last one will still apply if you just go full Kubernetes, but again, the other things don't. When it comes to costs, this is just a good thing to mention, is that a lot of times focus is on, hey, if you go serverless, you're going to pay less. It is almost true all the time. The thing is, if you have an application that has a lot of load, usually you might actually want to consider a not serverless option, because non-serverless options, things like Kubernetes clusters and stuff like that, they usually are priced a little bit better because you're getting a bunch of discounts for sustained use and all these kind of things. If you don't have 100% load or user pressure on your applications all the time, then serverless is a good thing. So think about that, because it's a kind of an important thing. A lot of people would just say, oh, serverless, that must be cheap. But then if you have a lot of traffic, again, if you have a lot of traffic, constant traffic to your application, it actually might be more expensive. What I would say, if you're using something that actually can provide you with costs, like a cloud providers, public cloud providers, they usually have calculators. Put it in there and calculate. If not, there are also tools that you can install on your infrastructure that gives you a bit more information about footprint, like CO2 footprints and all this kind of thing. So that is that part. Now let's talk about optimizations. And if we have time, I do have code, and I can actually show you some fun things as well. I want to talk about a few at least ways to optimize your application without actually changing anything in your code. Obviously, there's a lot of things you can do in your code, and you can do a lot of things to optimize it by using proper data structures, to proper architecture that fits your needs, that fits your user usage, and all those kind of things. But we're not going to talk about that, because this is a different story. I have a different talk where we talk about data structures and things like that, and compare different types of collections, for example, in Java, so built-in collections, something called Eclipse collections, and some other things, and see how much memory it takes, how much, it will still influence your, the green thing, like, your credit card or environment and all these kind of things, but we're not going to talk about here. If you want, ping me, I'll show you the slides. They're actually on GitHub, and there are a bunch of videos of us talking about that as well. But again, here we're talking about optimizations without touching your code, more or less. Right. So one thing is, you need to think about what you're running your stuff on. And I'm not really going to say, this is just a random, semi-random list of runtimes, but it's going to be different, and I'm not going to sell any of those saying like, hey, this is better than something else. It might sound like that, but I don't really mean it, because it will be different from your usage, and it kind of, the good consultant answer, it depends. But the point is, those will be having a little bit different. So when it comes to Jakarta EE and microprofile and all that, those are specifications. It's up to those and many more to implement them. And when they implement them, they do it in a little bit different ways. And if they do it in a different ways, you will have different set of bugs. Yay, fun, debugging things. If you're really, really bored with your set of bugs, you just change a runtime, and then you get new kind of bugs. It's so much fun, right? No joy? No excitement? Okay, fine. I heard one person laughing. That's good. I made one person's. I made a day of one person. I can call it a day. Okay, 2 now. We're 100% increased. This is good. Should be 4 by now. And anyway, let's not, no, we're not going there. So runtime is different, and they are different in many ways. How much memory they use, how much time they will take to boot up, how much footprint there will be, and all those kind of things. So you need to really think about those kind of things and just pick something, not because somebody at a conference said it's an amazing thing, but you tested and you actually seen it different. The other thing is that container image is really different. Container image is not container image. Docker image is not a Docker image. We always talk about container images as Docker images, but in general it's OCI, and it's it can be run on different things and all that thing. But the point is, a lot of things differ when it comes to container images. First of all, image size, because I'll explain why. I mean, for some of you it might sound obvious, but for some of you it's like, I don't care if it's like 100 meg or 30 meg or 200 meg. Well, we'll see about that. Image lifecycle is an important thing, and that's where also image size plays a role, because it's about what happens to your image when it's being scaled. And remember, I mentioned that already, like from the time you built an image and deployed it, or at least created a deployment and said this is how it should look once it's in use, from that time till it's actually serving its first request, a lot of things have to happen. Especially if you think of a platform, typically you would call it through a URL, through HTTP, right? You have to send a request to something. That something has to look at it and it's like, oh, what is this thing? Oh yeah, that's that application. Okay, cool. I have to go to whatever that application is running on some kind of serverless. Let's say it's Knative. And then Knative has to, or CloudRun or whatever, that CloudRun thing has to say, okay, do I have an instance running of it, or did I scale it down to 0, or I have nothing? Oh, I don't have anything. Okay, cool. Now I have to go to container registry, find the container, find the correct image of a container, stream it, or actually copy it to myself, create an instance of it, boot it up, boot an operating system on top of the in the container. First, I have to copy a container, and that's where the image size comes in. And a lot of cloud providers and stuff do a smart thing. They actually stream containers because all the containers are layered. So they would just stream layer by layer, so we can actually start booting those layers while the other ones are being copied still. So it's kind of a cool optimization. They do it for you, but it's kind of cool to think about. But you copy a container, now you have to boot whatever is in the container as of layer of operating system. After that, you need to start your JVM. After that, you need to start your application. And when your application is ready and actually responds to a readiness probe, then the cloud provider platform thingy will redirect that original HTTP request to that, let the application do its thing, process it, answers with something, and then redirect an answer to you. A lot of things, right? I spent like, I don't know, 5 minutes or something just talking about it. You would not wait 5 minutes for it to happen. You would not even wait 5 seconds for it to happen. You want to happen like this, in just milliseconds. But there's still a lot of things that has to be done. So that's why you really need to be careful with your image sizes, with all this kind of optimizations. Another thing you need to think about is, and that will be more important when we will start talking about native images and stuff like that, is build time. Because if you're deploying once, I don't know, let's say even once a month or a week or a day even, once a day, it's fine. It doesn't matter. If it takes a little bit longer, if it takes like, I don't know, 10 seconds or 10 minutes to build, it's not that bad, because, you just click on deploy and, you will have your tests and everything running and builds, and, it takes 10 minutes, it's fine. You go grab a coffee and everything. It rolls out, does all the gradual deployments and blue-green deployments and, canary things and all these things and tests and routes traffic, and all the magic happens. And 10 minutes later, you have a new version of your application running. It's fine, right? If you're doing many times an hour or many times even many times a day, then it starts to matter, because Now you're losing a lot of time every time you deploy a new thing. And there is so many cups of coffee you can drink a day, right? At some point, it just kind of becomes boring just to sit and wait and see that happen. So it's an important thing to think about a relationship or ratio of time to build a new image versus number of deploys or builds versus resources it actually takes to build it. Because a lot of times, it also not only will take longer time, but at least in one way or another, it might require more hardware to do that as well. Or to make it build as fast as the fast builds, you have to add more hardware to keep the same time. So again, you're using more resources. So you need to think about that. And well, when it comes to container images, you also have to think about, obviously as a good developer, as I am, I did slap on the security stuff bullet point as the last one, because we'd never do that, right? No? Okay. It's an important thing to actually be able to scan and update and all that, and you want to be able to rebuild those images whenever a new vulnerability is appearing and all these kind of things. You need to be able to scan, update, redeploy and all that, and you want that to be automagic. And all that will also be influenced by image lifecycle, by image build time, by image size, and all that. So all of those, it's a spaghetti of dependencies between those 4 points. And there are probably a bunch of other things that I'm not thinking about as well. And then, they will have things that, like Quarkus. There are actually also similar response times and similar improvements we've seen in other platforms as well, or runtimes. Quarkus was the first one, then Helidon kind of came in and matched a lot of this, and it's really, really cool because it used to be, so this is how it used to be, typical runtime or application server or whatever you want to call it, is in gray. So the biggest chunks, that's how it used to be, and then the JVM version of Quarkus was, it was not even half, with rest with CRUD, it is what, 1/4, 1/5 of the time from the gray, from 9.5 seconds to 2 seconds, so it's 1/5 roughly. And then you have the green one that you can barely see, this little thingy, that was the native image. We'll talk about that in a second. But this is what was with CRUD, and without CRUD it was even more intense, right? So you went from typical startup first response or cold start of 4.3 seconds to 0.016 seconds all of a sudden, right? If you take the 2 extremes. Again, this is Quarkus. You can do a lot of similar things with, for example, Helidon as well. But so that's one of a way of optimizing it, is to actually pick a right runtime that will actually do this kind of things. And here, between the gray and blue, so the 2 bottom things, you only thing you had to do was just to change your POM file a tiny little bit. For native, it's a little bit more. You need to add, it's still POM file, but it does a bit more. But we'll talk about that in a second. And the second is now. So this is a native images, building native images with GraalVM that also makes it possible to optimize things even more. So as I said, you go from 0.9 seconds to 0.016, or from 2 seconds to 0.04. So you can actually do, you remember when I talked about the lifecycle, I talked that, well, you need to boot up JVM, and JVM takes also some space in memory and on disk and all that. Well, you can avoid all that. You can use GraalVM with Quarkus or with Helidon or with some similar things like that, where you can actually compile it down to binary. So you don't have JVM anymore. You have a binary executable that will run without any JVM. And well, it's a good thing most of the times, because you will have an even faster startup time. Well, we saw that. You'll have a smaller footprint because you'll have less memory and less disk space to be used, because you don't have to care about JVM anymore. But the downside is that you will have no JVM optimizations, because JVM does a few things, because usually when you see a cold start of JVM applications is a bit slow, and then kind of slower. It's not slow, but it will take some time, and then the optimization will kick in, and the response times will go tiny little bit down. So you have a little hump there on top. Here you will not have that hump because there will be no optimizations. It will be just like response and then linear kind of from there for the same requests and all that. And it might also mean longer build time, or you need a bigger server because now you have to compile things down to a binary, and that takes longer time. I know that there are some companies where they deploy too many times a day. They don't really, they are willing to sacrifice the response time of those milliseconds that they win using GraalVM versus because it's too much for them to wait for those to build. So, there is a thing that you kind of need to think about that. Most of the times, one or the other will not matter and you'll be fine, but you need to try those two options and see if you can squeeze some more optimizations out of it. So now, different story. This is the crack I wanted to talk about, and that stands for Coordinated Restore at Checkpoint. And that is a something that was created by Azul and was kind of given to OpenJDK as a project. It is still supported in different, you still need to have a specific JVM to get used, to get benefits of it, but it's built on top of kind of known Linux thing. Inside a Linux kernel for quite a long while, we had something called Cryo. You've heard of Cryo, anyone? That does the hibernation and all this kind of things in a Linux kernel? Well, so this is a thing on top of that. So what happens is that, so when people ask me what it is, I usually ask them if they have remember the good old times when we had machines like, back in an era of Windows XP and stuff like that, you would have an option to turn off your computer or to hibernate. And I'm not talking about the framework for database things, Hibernate operating system, where it would just dump the memory contents onto a disk, and then next time you turn it on, it would go much faster because it would just load everything, and then you had all your applications up and running and everything, and it would actually probably start even faster, while back in the days we would have like spinning disks and all the fun things. This is kind of similar, but just for containers. So you boot up your container. Instead of having those, you see the uphill thingies, every time you start a new instance, you have to do all that, loading into memory, loading everything. Now you load, you pre-warm your application, do whatever you need to do to make it warm enough. You take a snapshot, you store that onto a disk, you use that snapshot next time you build your container, and that is the second container that you're using to scale afterwards. And then you don't have that hill thing. So next time it will be just ready to serve things right away. I do have a demo that actually shows a bit of a difference of how it actually works. So it's based on a kernel, Linux kernel project called Cryo, but they also created a wrapper on top of that called Warp. IBM has a similar thing. It's called Instant On. And for that, you need to have OpenJ9 as a JDK, as a JVM, sorry, or OpenJDK build. For this one, you need to have Zulu. And so that's what I'm saying. It's still not like available for all JVM builds or distros, but something is gonna happen at some point. We'll see what. And obviously, since it's a Linux thing, it only works on Linux, both of them. They're very similar in stack-wise, but this one has both API and a command line tool, while the other one has just one of them. But it's very similar. Here you can actually see both images of Helidon and Quarkus with and without crack. You see that Helidon, and this is actually a fun thing. So we did it on 2 different machines. I actually did it on 3 different machines. So this is an Intel Mac, the good old ones. It's an i9, so it's pretty powerful CPU, right? And then you can see that in Helidon it's like 2.4 seconds without crack startup time. So just cold start till it's ready to serve requests. Boot up of a container, 2.4, which is really fast. But then with crack, it's just 1.3, and with Quarkus, it's even it's smaller difference, but it's still faster. So 1.3 and 1.2. This is on an Intel, and it's the reason I'm saying it's not very scientific is just because it was measured on my machine. I've been running it 10 times. I plotted into a sheet, and I did average. This is average of, I don't remember if I did 20 or 10 or something runs. This is on M1, and you see the numbers are kind of a little bit different. I keep on switching back and forth so you can actually see the difference. This is i9, this is Mac M1. And I did the same thing. This is M2. And I also have M3. So, you know, we're getting like fun, interesting results, but they're kind of similar. See, here is the same. It goes faster. So now we're on 1.4 seconds, but still it's like half of the time with Helidon and kind of half of the time with Quarkus as well. Right. So if you want to see all those things, and I can show you some of that live if we have time, but all of that is in that repository called random strings, and the repository link to my GitHub is also at my this rustam.no page, so you'll find the link to GitHub there as well, so you don't have to type the whole thing, but look for a repository called random strings, and there are different parts of the different things that I've been explaining. So for example, things about how to change your runtime, how to change different switch from Quarkus to Helidon to whatever else. It's right there. It's under local build and run, and I'm not touching code at all. The only thing I'm doing is changing POM files. The same thing, how to build and create a GraalVM native images and containers of that. It's there, and also crack. There is a bunch of shell scripts, well, 3 shell scripts that I'm referring to that I've created, and those shell scripts are there just to show you a sequence of things that you need to do. So it's a bit of kind of a little bit overly commented shell script just because of the learning thing. All right, final thoughts, and then we can see some code. So again, when you're optimizing things on, well, it says Google Cloud, any cloud. It should have been like Star Cloud, any cloud, anything really. Anything serverless mostly, but works also for other things. You need to think about runtime, because runtime's different, the startup times, footprint, and all this. I actually had an issue with, for example, OpenLiberty for a while when it would take enormous amounts of time, but then I found the way to optimize that as well. And that also goes under optimization because it has nothing to do with my code, but it had to do with how much I'm loading of things. Instead of loading, for example, whole Jakarta EE full profile, I could just load only core profile and this kind of things, and it did reduce time quite a lot, and it's kind of interesting. So optimizations of that kind is important, and think about what you're loading and what you have to load and what you don't have to load is very important. That means that you need to have a little bit more intimate knowledge of what you're using in your application. So it is a bit heavier, but you know, you get benefits out of it. I went from 25 seconds boot time to 4. Huh? Difference, right? And that was just by changing the things that I'm importing. Obviously, you need to think about footprint. Obviously, you need to think about whatever your application is written in or using, if it's Jakarta EE, Spring Boot, Micronaut, you know, all those kind of things. Runtime has to support it. It's fine. Where you deploy it, again, do you need a VM? Do you need a cluster of Kubernetes nodes? Or you can go function or serverless. Maybe you don't even need full container serverless. Maybe you can just deploy it as a function on whatever, because you know there are like FN project, which is kind of open source version of the functions. There are lambdas, there are cloud functions. There are a bunch of like different cloud providers call it a bit different. But if it is small enough, it's a tiny little thing. doing one thing at a time. Maybe you don't need the full serverless container as well. And then let the cloud provider do optimizations for you and let it make it fast for you. So you don't have to think about all the things that I've said, but now you know what the kind of things they might do in the background. And then you need to optimize for, scaling to 0 or scaling, not even to 0, but just scaling, horizontal scaling, and auto-scaling in general when you're scaling both up or down. Startup times, container sizes, and build time and resources and all this kind of things we talk about. Right, so while I'm pulling up some code, and I can just show you a little bit of things, we have not that much time, but this is a Slido link. This is the link where you find all the other like social media and GitHub links and stuff, or something, I don't know. Go there, type your questions, and I'll see if I can pull them up here on the screen. Let's see if there is anything yet. Oh, you're funny. I kind of feel, I don't know, what should I say? I think the answer is yes, no matter if it is, how many percent it is? It's like, okay, 1, 2, 3, 6, 4 out of 6, so that's 1/3. So 60% similarity to my name, but it's still, no, actually, jokes aside, it depends, because Java is really good for some things. Rust is really good for some other things. It's really fast and all that. But when you think about enterprise support and enterprise tooling and enterprise kind of grade things, I would still stick with Java. But I know a lot of people trying Rust and all this kind of thing. So it depends, but it is when we talk about enterprise things, we talk about full kind of package builders, things like Maven and stuff like that. We talk about testing frameworks. We talk about like deployment, all the support and all these kind of things. I would still go with Java. But the thing is, again, like if we think about containerization and serverless, Java is supported on a bunch of things like Cloud Functions and all the other things like Lambdas, whatever. Rust, I think last time I checked, is not, because then you will actually need to build your own full-fledged container and do that serverless on that container, because most of the cloud providers do not support it out of the box. And now we're actually into the world of how to deploy our stuff. To kill the build time with GraalVM native image, would it take sense to copy and build image to the runner container and deploy it? I'm not sure. So the thing is, comment number 1, there are some really, really good people, GraalVM people here, so find them at the conference and talk to them as well. Number 2 is that very often when I build stuff on with a cloud of any kind, I don't have much of a control of all this optimization weird things I can do. It's usually just a pointer to a Docker image. So as long as it cannot do that in a Docker image, that might be a bit hard to do all these kind of crazy optimizations, but you can do it on your local machine. So, it depends. And also when you build your images, you actually have to think, one more thing is that you often have to think about the architecture it's going to be running on. Very often you will have in the background, if you use some tools, in the background it will actually build both Silicon and Intel versions, and then it will let you choose and pick and choose automatically depending on what you're requesting from your platform, or what your platform that is requesting an image will, so it will serve that. But I'm not really sure the answer to that. I think because you'd still need to build that image, so I'm not sure it's going to help unless I misunderstand your question. But let's talk about that afterwards. We've played with GraalVM and it was a nightmare for existing application, not only a few changes. Yeah, I mean, for a large application, you need to, yes, you need to figure out if all the features, all the things that you're using is supported and, all this kind of thing. So it's not just like, oh, you just do that. And for smaller applications, in my case, it was. And in a lot of cases, it might be. In some, if you're using some specific things, it might not be. So it's not for everyone, but it's possible to make it work. It is, and also there are very helpful people that can help you with this kind of things as well, both online and both also from, if you have enterprise support, whoever is selling you that support might also help you with that. Performance comparison after JVM JIT warm-up. Yeah, I actually did that a little bit, and it was very different. So, how much time do I have? 4 minutes? Okay, we can talk about that. So, there are platforms that automatically support crack out of the box, and there are some frameworks that do not. Jakarta EE does not. So you have to build things yourself. And that's why I actually created a demo and all that, showing how you can do this kind of things. And there you do have a lot of control to decide when you take that snapshot. You can actually just do it right after boot, or you can do some warm-up, and then you can take another one, and so on, so on, so on. Things like, for example, Spring Boot. They do have out-of-the-box support for crack, but what they do is that they take a snapshot from the moment the application is up and running, so they don't do that. If you want to do another one after warm-up, you actually have to take yourself a snapshot and do some changes and do some things. And there are differences. So after warm-up and if not warmed up application, there is a little bit of a difference. So you do gain even more milliseconds by doing that. So yes, there is a difference. Native image free, or do we need some license? Well, there are both versions. So short version, yes. It depends, but you have, so the one I'm using is the free version, but there is also enterprise support and enterprise things as well. So it depends on what kind of needs you have and what kind of agreements you have with the big O. I mean, just so that said, I don't work for Red Hat, Oracle, Google, or any other things I'm mentioning. I'm working in a fintech industry in Oslo, Norway. So this is just me playing around with things. Do you know any companies who actually use GraalVM native image successfully in production and actually still maturing technology? Yeah, I think I do. I mean, I know that people have tested it on several companies in Norway, and they've used it. The only thing, one of them ditched it just because of the build time things. I know my ex-colleague sitting right there, he's using it for his stuff. I'm not sure if that's a company, but they do run production application for his hobby project using that. So it is being used, and also I think Oracle people can also provide you more information about like usage and example and stuff. But I do know, yes. What do you mean optimizing scaling to 0? Well, geo-redundancy policy and plan, or simply shutting down? Actually both, but mostly I mean when I talk about 0 is that you have at some point, if there is no usage over time on your application, it will just it will stop the container, and maybe even whatever, you don't have much of control what platform is doing. So maybe to save space, they will even delete the container image until you request it again. So this is what I mean by 0, so then it will at least stop the image, and that means that it will have to start and restart the whole image as well. And that also means that you need to think about things like keeping state or stateless applications as well. There are ways of doing both, but you need to be careful with that when you're scaling down to full 0. But again, it doesn't really matter if you're going from 0 to 1 or if you're going from 1 to 10. You still have 9 other containers if you go from 1 to 10 that has to boot up, and then you need to optimize for those as well. So startup times most of the times, and startup times off a container, off whatever JVM, whatever thing is there, plus the runtime, plus your application on that runtime. So there's a lot of things that needs to happen, right? Thoughts on Project Layden? Yes, so that is, yes. So Project Layden is one of the reasons, I think, again, this is my personal opinion, don't quote me on that, it's going to be recorded, but you know, don't quote me on that in a sense that I'm a little bit on a thin ice, but one of the reasons why it's not like into the mainstream things like crack and stuff yet, is just because they trying to figure out how it's going to play around with Layden that's doing some similar stuff. But the way I understand it, they're doing it much lower level, because all this kind of instant on and crack and all the other ones that they do on top of that is still needs to be done, and Layden will do the groundwork, the footwork, but then the way I understand it, again, I think you will still miss that thing on top. But again, I'm not a lawyer, kind of hashtag. I'm not a expert on, like, you know, this one I'm a bit careful on saying something very, very 100% kind of sure. So, okay, now we have time end. Yeah, okay. I'm going to steal a second from your time, and I'm going to say, if you want to see something, developers and estimates, right? So we're gonna create an image with a checkpoint live. I did have created already, so this is kind of mostly cached. You see it says creating checkpoint. This is because it's actually gonna wait for 30 seconds and halt and then do a dump. What you will see here is that the folder here, which says crack files, will become full with a file in it, and that will be an image file. Now, see, it's there, core image. And now we're going to do restore, and it's already up and running right now. And it took 1.495 seconds to do that, and that's just on my machine doing anything except for just loading the crack image instead of doing that. You can also do startup with no crack. You can look at all the scripts and everything in oh, this is fun. It actually took shorter time. This is cool. This is an amazing demo. This is fun. Okay, well, there is scripts there, so have a look. I might have, I was fixing those scripts yesterday at night, so. But the cool thing is, one more thing, and I'm done, is that you can actually do all this crack optimizations and all that, and you actually import all the crack things like API, and they will be able to run on any JVM that does not support crack and will give you no errors and no optimizations, nothing will happen. But if you're running it on the one that supports it, it will actually kick in and do that. And then you can actually create listeners like this, startup listeners, that will actually print you elapsed time kind of stuff, this is also kind of fun thing, how to create the listeners that will tell you about things that is not out of the box. So look at some code that is in that repository, and then you can find a lot of fun things. There's also fun things that where I also do multi-stage builds and also do some optimizations for doing Maven builds inside the Docker containers and all the fun things. We can talk more about that. We can do another talk on that, but we don't have time. So at this time, I'll just say thank you, and this is how you find me on social media. So thank you all for joining me.